everybody, in this video I am going to show you how to solve for this expression. At first glance it might look a bit big and scary, but it's actually very easy to solve. All you have to do is to call this whole expression x, and then you can write x is equal to under root of 3 times under root of 3 times under root of 3 and so on. And then I'm going to bring both sides of this equation to the power of 2. So then I have x to the power of 2 is equal to 3 times under root of 3 times under root of 3 times under root of 3 and so on. Does this look familiar? Yes, this is exactly the same as what we had up here. So I can just call this x again. And I have x to the power of 2 is equal to 3 times x. This is equal to x to the power of 2 minus 3x equal to 0, and that gives us x is either 0 or 3. But we know that under root of 3 or under root of 3 times 3 or under root of 3 times 3 and so on, these are all positive numbers. None of these are negative numbers. Therefore, we know that x cannot be 0. So x is equal to 3. Now in this video, I went straight to solving for this equation. But if you want to do this problem thoroughly, you have to first make sure that this sequence is actually converging into a certain value. And to make sure that this is converging into a certain value, there are two conditions that you have to check for. You have to check if the sequence keeps increasing and if the sequence stays below a certain number. So if I call square root of 3 x1 square root of 3 times square root of 3 x2 and so on, I have to prove that x1 is less than x2 is less than x3 and so on. And if you calculate each of these values, they seem to keep increasing and they seem to be all converging to 3. So if xn plus 1 is equal to square root of 3 times xn, and if xn is less than 3, then that means xn plus 1 is less than square root of 9, which is 3. So once we show that each expression keeps increasing and it never passes a certain number, which is 3 in this case, then we can safely say that the result of this expression is 3.